A relative extreme in calculus refers to a point in the domain of a function where the function reaches a relative maximum or a relative minimum. In other words, it is a point where the function value is either greater or smaller than the values of nearby points. Mathematical is a relative extreme of a function is a relative maximum if or all in a neighborhood around. Is a relative minimum if for all in a neighborhood around. There is a point here typical from my identifying the critical points of the function where the first derivative equals 0. Or is undefined using additional tests like the second derivative test. It is classified them. Yeah. A relative extreme is a point where a function reaches a maximum or minimum value in a specific interval around that point. A relative maximum is a point where the function reaches a value greater than its neighboring values. For example, imagine a mountain. The peak is relative maximum. Yes, in graphic. Okay. Yes, is an example.
To determine if a critical point is a relative maximum or minimum, we can use the second derivative test if the second derivative is negative at the critical point. We have a relative maximum. If positive, we have a relative minimum. If the second derivative is 0, the test is inclusive.
Hello, today we are going to solve the derivatives using the first derivative method. Remember to determine the maximum and minimum points of the functions. We first need to find the critical values. The function is if x equal x to the power minus 4x to the power of 3 plus 10. In this case, the constant term plus 10 does not affect the behavior of the curve, as it only shifts the graphs upwards without altering the shape of the curve at the maximum and minimum points. Step is to differentiate the function f(x). Recall that when different x to the power to 4, the exponent 4 comes down to become 4x to the power of 3 and the separate one from the exponent. Similarity when differentiating minus 4x to the power 3, the exponent 3 comes down to become minus 20x to the power of 2. Before the derivative of the function is f(x) equal 4x to the power 3 minus 12x to the power of 2. Next, we factor the derivative is f(x) equal 4x to the power of 2 in parentheses x minus 3. Each factor equals to 0 is 4x to the power of 2 equals 0 and x minus 3 equals 0, x equals 0 and x equals 3. So the critical points are x equals 0 and x equals 3. To classify the points x equals 0 and x equals 3, we can use the first derivatives test. We know that if fx changes from positive to negative and point, that point is maximum. In fx changes from negative to positive and that point is minimum. The point x equals 3 is the maximum since the derivative change from negative to positive at the point. If we plot the points x equals 0 and x equals 3 on the Cartesian plane with scale of 20 units the x-axis and 1 unit on the x-axis, we can mark x. Once we have found the critical points, we can graph the function. The constant term plus 10 will only affect the vertical scale of the graph, but does not change the shape of the curve. The point x equals 0 is minimum since the derivative changes from positive to negative, that it's